How do we graph linear equations? At this point, you should already be familiar with the fact that a linear equation has two different types of variables. Generally, it's shown as an x and a y, and they have no exponents on them. Okay, we would say they're to the first degree because it's to the first power. It's like an invisible exponent there. So if you ever see an exponent beside these variables, it's not a linear equation. And then you're in for a whole different type of ball game trying to graph that. But we're going to graph two famous types of linear equations. The numbers 1 and 2 are called standard form equations. Okay, and that's where the x and y are on the same side of the equation. The other side is called a slope-intercept form, and that's because the number that's in front of this x we would call the slope, and then the number that's tagged on at the end of it we would call the y-intercept. So for short, we call it the slope-intercept form is the types for 3 and 4. Um, there are all sorts of different ways to graph equations. What I'm about to show you is not my personal favorite, but it is a serviceable way, and if the equation is simple enough, you can actually do it pretty easy. If you have a fraction in there, it can make some things interesting, especially if your math skills are not up to par in certain areas. But if it's easy where it's just mainly like an x and a y, or there's only one number in front of the variable and then the other number, like in the slope-intercept form where the y is by itself, this is still a pretty good method. So let's take a look at number 1. We want to be able to graph it, and when we graph something, we need to plot a point. And a point comes with the coordinates of an ordered pair. It's an x value followed by a y value. And nice enough, we have an x and y for our variables in this equation. So ask yourself this: what two numbers could I add together, because there's this addition being shown, to equal 4? You could say, well, 2 plus 2 equals 4. You could say 1 plus 3 equals 4. You could say 4 plus 0 equals 4. There's so many different ways that you could do it. You could flip them around backwards and say 0 plus 4 equals 4. And I just now realized I wrote a 0 right here, so let me fix that. And then ask yourself this. I want to be able to graph it on a Cartesian plane, so here's our x-axis. And here's the y-axis, and we need to put different points on there, at least 2 points, but my preference would be find 3 points, so that way when you graph it, all 3 would be on this line. What's the x value for this one? The x value is 2 and the y value is 2, so let's make that an ordered pair. 2 is the first x value and y value is 2, so we use these right here. X plus y equals 4. And then we can do the same thing right below it. This 1 was an x, and see the second number was a y, so we'll call that one a y. And now we're going to put these 2 points on our Cartesian plane, and I'm actually going to pull one up right now so that way we can see it. I have to flip that over there. There we go. And now let's just go through and graph this 2, 2. So x value is first, so I go to positive 2 and then positive 2 for the y value, and there it is. And here's 1, 3, positive 1 on the x value, and positive 3 on the y axis. And there we go. You would draw a line and connect them. My computer program is not doing it, but you really need to put arrows on the end of it, of the lines, so that way you can show it keeps going in both directions forever. Now, do you see that this point right here would be 3, 1? This is the x and this is the y. If I add those together, would it equal 4? Yes. What about this one? That's 0, 4. There's the 0, and there's the 4, the x and the y. How about this one right here? That's 6 on the x-axis, and on the y-axis it's negative 2. You tell me, is 6 plus negative 2 equal 4? If it does, then basically it's proving that every single point on this line, we can actually steal the x and y values from those points, those coordinates, and plug them into this equation, and it would make it a true statement. But if I take a point that's not on the line, like let's just say I choose this one, let's see, that's -1, +2. -1 plus 2 equals 1. It doesn't equal 4. Because it doesn't equal 4, it's not going to be on that line. So let's go through and look at a couple of other options. And here we go. And don't try to be cute. Don't try to make it hard. Make it as easy as possible. What two numbers minus, one minus the other equals 2? How about 2 minus 0? Hey, that works. How about 3 minus 1? That equals 2. And so now we're going to steal these values, the 2 and the 0 and the 3 and the 1. And instead of writing the 0 sign down here, let's just change it and make it a comma, so that way that's our coordinates and that's what we're going to graph. And we already know that they're equal to 2, so let me just erase this. I would say these values, when you plug them into this equation, makes it a true statement. So let's pull our graph out and let's get to graphing. 2, 0. Let's see. 2, 0. So right there. 3, 1. 3, 1. So it looks like our line is going to be going up like this. Okay, and that's me hand graphing it there. So let me actually let the program do it for us. 2, 0, 3, 1. There we go. And now let's see what else is on this line. 4, 2. That was a 4, 2. Does 4 minus 2? Because it's the x value first, so here's the x value minus the y value. 4 minus 2, does that equal 2? Yeah. Let's try this one. -3. No, I'm sorry. -1 is the y value. -1 minus -3. Well, we keep this one the same. We would change this one. So keep, change. -1 plus 3 is 2. So every single point on this line makes it true. If we try a different point that's not on the line, like here's 0, 0, what's 0 minus 0? It's 0. So we don't get the 2, and that's the reason that it's not on the line. If we can come up with any two numbers that you subtract to get 2, it will be on this line. If you subtract them and you don't get 2, it will not be on this line. If it's any other number than 2 for the answer, it won't be on the line. So we've just shown all the possible solutions for this equation by graphing this line. And remember, put the arrows on the end of your line after you graph it, okay? We're not graphing line segments. We're graphing a linear equation, which is the graph of a line. Now, let's go on to number 3. Now, this one is a little bit different, and if you felt good about the first ones, then possibly this could be causing you some anxiety right now. This is called a slope-intercept form, and where that comes from is this first number in front of the x we call the slope, and this is called the intercept, the back number that doesn't have the x beside it. We'll get to that later, and you might like that style better, but I'm just showing you this way of plugging in numbers for x and working it out. Now here, we don't have to ask ourselves what plus what equals this or what minus what equals that. Instead, just plug in a small number for x. Just make it up. I suggest starting with 0, then 1, then 2. If after 2, if you can't fit that one on the graph, I would go back to -1, maybe -2. It all depends. If you use one of these 5 numbers or 3 of these 5 numbers, you can almost always graph almost any line on a small Cartesian plane. So 0, 1, 2, -1, and -2. So let's start with 0 first. Y equals -2 times 0 plus 2. Okay, so -2 times 0 is 0. So that's like it never existed. And 0 plus 2 is 2, and so do you see y equals 2? So when x was 0, the output, excuse me, y was 2. Now, what about if we use +1? Okay, so here is +1 in for the x. -2 times 1 is -2. And what's -2 plus 2? 0. So y equals 0 when, what do we plug in for the x value here? The 1. So when x is 0, y is 2. When x is 1, y is 0. Technically, we've got enough to go plot it right now, but I just want to show you a third one real quick. Y equals -2 times, let's plug in -1. And now I put the -1 in for the x. So here's the x, there's -1, and don't forget the +2 up here at the end. So -2 times -1 is +2, and 2 plus 2 is 4. Y equals 4. Now let's go and plot these 3 points on a graph. I'll make this one a little bit bigger. There we go. 0, 2. So here's 0 for the x value and 2 for the y value. Here's 1, 0, 1, 0. And here's -1, 4. -1, +4. You can see it looks like it's going to make a straight line, so let's just check it. Yep, that line goes straight through it. All 3 points are on the line. Congratulations, you have successfully graphed the equation of y equals -2x plus 2. And there's all sorts of other information I'm going to be sharing with you. This is the basics of how you would go to plug it in for these 2 types of equations. You know, later I'm going to show you that the line is actually going down to the right. See, I know it's going up to the left, but we always look at what direction is it going to the right. If it's going down to the right, it's going to be a negative number in front of that x. If it's a positive number in front of the x, it's going to be going up. And then I've got to show you, well, why is this a positive x here? It's because it's not in slope-intercept form. And so you've got to understand that this is just a very basic beginning lesson of how to graph these equations. We've got other methods coming that you'll probably like better, some shortcuts if you would. And if you're not liking this, I need you to get just enough to basically understand this. These points on the line, these points that you graphed, make the equation true. And once you get the line graphed, every single point on this line is a solution to that specific equation you've been wrestling with.